Cloud engineers know all too well that network inefficiencies and misconfiguration can result in high costs, poor performance, or both. But diagnosing inefficient or poorly configured traffic patterns in highly complex and dynamic cloud environments can be complex without complete visibility. In this demo, we'll show how Kentik Journeys helps identify a case of intra-zone traffic incurring unexpected transit gateway costs due to asymmetric routing. This will help us target potential cost savings for our business. Let's begin by asking, show me AWS intra-zone traffic going over the transit gateway in the last week. This query aims to identify traffic within my AWS cloud that unnecessarily traverses a transit gateway despite originating and terminating within the same AWS region and zone. Such traffic incurs additional costs that could be avoided. If a potential portion of this traffic occurs between the same VPCs, VPC peering might be a more cost-effective alternative than using a transit gateway. Kentik AI generates a filter tailored for AWS traffic. It ensures the source account and zone match the destination account and zone, indicating intra-zone traffic, but with the destination gateway type set to transit. We notice that this traffic is occurring in two zones. We're particularly interested in the traffic spikes within the US East 2A zone. We'll focus on a noticeable spike from the afternoon of November 17th. Now we'll include IP addresses and instances in this view to gain deeper insights. The majority of the traffic is going from IP address 10.67.200.223 to 10.68.200.128. We'll refine this view to focus exclusively on the traffic between these two instances by asking, filter this for traffic between 10.67.200.223 and 10.68.200.128 in both directions. This filter created by Kentik AI correctly isolates traffic between these IP addresses in both directions. However, it's peculiar that the traffic appears only in one direction. We also want to identify which applications are being used between these two instances. We'll adjust the view to remove zones and include application details and destination ports. Given that the traffic appears one-sided, we need to verify bidirectional connectivity between these instances. We'll use Kentik's newly added Cloud Connectivity Checker in Journeys to do this. We'll ask, check connectivity between 10.67.200.223 and 10.68.200.128 on TCP port 3020. Journeys will determine which ENIs, instances, or subnets require testing based on the involved IP addresses. The connectivity checker uses metadata from our AWS cloud environment, collected via API, considering all routing tables, security groups, and network access lists along the path between the two AWS instances. The connectivity checker results show the traffic from 10.67.200.223 to 10.68.200.128 travels over the transit gateway, but the return path uses VPC peering between the VPCs containing these instances. This explains why the return traffic was absent in my previous query, which focused solely on the traffic over transit gateways using the destination gateway type dimension. By removing the transit gateway filter, we can now confirm bidirectional traffic between these IP addresses. For clarity, we'll also remove applications and ports from the view. Finally, we'll need to access our AWS account to create an appropriate route that leverages existing VPC peering instead of routing traffic over the transit gateway, thereby reducing our AWS network traffic costs. This concludes our Kentik Journeys cloud demo. Thank you for watching how Kentik Journeys enhances your cloud environment's network and helps troubleshoot costs.